Every year in America, more than 35 million households use firewood to heat their homes, cook food, or enjoy cozy nights by the fireplace. But have you ever wondered where all that firewood actually comes from? How do we turn massive logs from the forest into the neatly cut, kiln-dried firewood you buy at the store? Today, we're taking you inside a supergiant firewood processing plant, where millions of tons of wood are harvested, split, dried, and packaged in a mind-blowing process. The journey of American firewood begins in the forest. Long before it ever reaches a fireplace or campfire. Across the United States, forests cover more than 750 million acres, and every year they provide not only lumber for construction, but also millions of tons of wood destined to become firewood. Contrary to popular belief, firewood isn't about chopping down perfectly good trees. Instead, much of it comes from trees that have been damaged by storms, attacked by insects, or removed as part of sustainable forest management programs. These removals help keep forests healthy while reducing the risk of wildfires. In the forest, teams of skilled loggers and advanced machines go to work. Modern harvesters can fell, strip, and cut trees into logs within minutes, something that once took hours of manual labor. Chainsaws are still common too, especially for trimming or cutting larger trunks into manageable lengths. Once cut, the heavy logs are lifted onto enormous logging trucks, each capable of carrying 20 to 40 tons of timber. These trucks travel from remote wooded areas to massive firewood processing plants that act as the heart of America's firewood industry. This first stage is critical. Without it, millions of trees damaged by nature or unsuitable for lumber would simply decay in the forest. Instead, they are given a new purpose: to heat homes, fuel wood stoves, and create the crackling fires Americans associate with comfort and tradition. By the time those logs arrive at the plant, they've already begun their transformation into part of the estimated 35 million cords of firewood burned in the US each year, representing an industry worth over $2 billion annually. From forest to factory, firewood proves that no piece of wood goes to waste. At the factory, the real transformation begins. Logs are unloaded onto massive conveyors where they are debarked, the rough bark peeled away to ensure cleaner burning. Next comes the cutting line. Giant saws slice the logs into standard lengths, usually 16 to 18 inches. Perfect for American fireplaces and wood stoves. Then, powerful hydraulic splitters crack each round log into smaller chunks. A single machine can split up to 10 cords of wood per hour. That's more firewood than one family could use in a year. Raw wood has too much moisture to burn efficiently. Freshly cut logs can be 40 to 60% water by weight. If you tried to burn them, they would smoke and waste energy. That's why the next step is kiln drying. Firewood is stacked inside giant heated chambers where hot air circulates for days or even weeks. The goal? Reduce moisture to around 20% or less. Kiln-dried firewood burns hotter, cleaner, and with less creosote buildup in chimneys, making it safer and more efficient. In fact, kiln drying is so important that many states require packaged firewood to be heat-treated, not just air-dried, to prevent spreading tree pests like the emerald ash borer. Once dried, the firewood is sorted by size and quality. High-grade hardwoods like oak, maple, or hickory are packaged for premium use, while softer woods like pine are sold for camping and outdoor fire pits. In giant plants, firewood is often automatically bundled, stacked, wrapped, and labeled in plastic mesh bags or shrink wrap. These bundles weigh about 40 pounds each and are shipped to supermarkets, gas stations, and big box stores like Walmart and Home Depot. Some plants produce thousands of bundles per day. On a national scale, Americans consume tens of millions of cords of firewood every year. That's hundreds of millions of bundles, fueling both homes and outdoor adventures. Not all firewood is sold as traditional logs. A growing industry compresses wood waste into wood pellets, small cylinders that burn cleanly in modern pellet stoves. The US produces millions of tons of these pellets annually, exporting large amounts to Europe, where they are used as renewable energy to replace coal. So the same log that might warm an American cabin could also become fuel for a European power plant. Proof that firewood has gone global. Firewood isn't just about energy, it's about tradition. For centuries, chopping firewood was a symbol of self-reliance. Today, modern machines can do the work of 20 lumberjacks in a fraction of the time. Yet the purpose remains the same, providing warmth, comfort, and connection. Whether it's stacked neatly outside a farmhouse in Maine, tossed into a campfire in Colorado, or bundled at a grocery store in California, firewood connects Americans to a timeless ritual. If you enjoyed this deep dive into the supergiant firewood processing plant, make sure to hit like, subscribe, and ring the bell icon so you don't miss more mind-blowing behind-the-scenes looks at how the world's most essential materials are harvested, processed, and transformed. Today, we're taking you inside a supergiant recycling plant where mountains of discarded wood are collected, sorted, shredded, and pressed into particle board. A material that has quietly become the backbone of modern construction and furniture making. Before we dive into this fascinating journey, make sure to like, subscribe, and hit the bell icon so you won't miss more behind-the-scenes stories of how the world's most essential materials are recycled and transformed. The story of particle board begins during the early 20th century, a time when the world was searching for cheaper and more efficient building materials. In Germany, 1887, engineers first experimented with bonding small wood particles using natural adhesives. But it wasn't until the 1940s, during World War II, that particle board as we know it today truly took shape. With raw timber in short supply, German inventor Max Himmelheber patented a process in 1941 to create boards from wood chips and shavings, materials that were once considered waste. His invention opened the door to producing strong, affordable panels without relying solely on solid lumber. Today, the world's largest particle board plants can recycle millions of tons of wood waste every year, turning what was once landfill material into durable boards used in homes, offices, and commercial spaces. Our journey begins with the arrival of truckloads of wood waste. Every single day, semi-trailers packed with discarded pallets, old furniture, shipping crates, and demolition waste pull up at the gates of this enormous plant. In the United States alone, more than 12 million tons of wood waste is generated each year. Instead of letting this wood pile up in landfills, plants like this give it a brand new purpose. Once the trucks unload, the wood is spread out in huge open yards. Here, workers and machines begin the process of sorting and grading. Clean wood, free of paints, chemicals, or glue, is separated from contaminated material. Nails, screws, and metal brackets are removed using giant magnets and metal detectors. The clean wood is stacked aside for the next stage, while unusable scraps are either burned for energy or disposed of safely. This careful preparation is critical, because particle board requires uniform, clean fibers to achieve strength and consistency. A single piece of contaminated wood could affect the entire production batch. After sorting, the wood moves into massive shredding machines. Picture enormous steel drums with razor-sharp rotating knives capable of chewing through wood at lightning speed. The shredders break the wood into chips and splinters, reducing bulky pallets and furniture into small, manageable pieces. These wood chips are then sent through another stage of grinding, where they're further reduced into tiny flakes and fibers. The goal here is consistency. Every fiber needs to be about the same size, so the final board has even density and no weak spots. Next comes drying. The wood fibers are sent through long, heated conveyor dryers. Here, powerful hot air removes excess moisture, reducing the content to about 2 to 5%. This step is crucial. Too much moisture would cause the board to swell and crack later. By the end of this stage, the plant has transformed thousands of tons of bulky wood waste into a fine, uniform raw material, ready to be turned into something new. Now comes the science that turns loose fibers into a solid board. The dried wood fibers are mixed with synthetic resins and adhesives. Inside huge blending drums, jets spray a mist of resin onto the falling fibers. The resin acts like glue, bonding the particles together when pressed. Some plants also add wax to improve moisture resistance. This mixture is carefully controlled. Too much resin makes the board brittle, too little makes it weak. Engineers constantly test samples to make sure the ratio is just right. Once mixed, the fibers resemble a soft, fluffy carpet. But the magic is about to happen. The resin-coated fibers are spread out evenly onto a moving conveyor belt, creating a thick mat of loose material. This mat can be several inches thick and many feet wide. From here, the mat passes through a giant hot press, one of the most impressive machines in the entire factory. Under intense heat, up to 400 degrees Fahrenheit, 200 degrees Celsius, and enormous pressure, hundreds of tons, the wood particles and resin fuse together. The mat is compressed down to the thickness of a board, usually between half an inch to an inch thick. This pressing process doesn't just flatten the fibers, it actually transforms them, melting the resin and bonding everything into a single solid sheet. The heat sterilizes the board, while the pressure ensures uniform density. When the press opens, what was once a loose pile of waste fibers has become a rigid, durable particle board panel. Freshly pressed boards are still hot and flexible, so they move into a cooling system. Giant fans and conveyor lines gradually bring down the temperature, allowing the boards to harden fully. Once cooled, the boards are trimmed to precise sizes using high-speed saws. The rough edges are cut off, leaving clean, uniform panels. Next, the boards are sent through industrial sanding machines. Sanding smooths out the surface, making it ready for laminates, veneers, or direct painting. At this stage, you'd be surprised how professional and finished the boards already look. What started as broken pallets and furniture is now a stack of sleek, standardized particle boards ready for use. Before shipping, every batch undergoes strict quality testing. Engineers check for density, ensuring the board is uniform, moisture resistance, simulating exposure to humid environments, strength, pressing and bending tests to mimic real-world use. Only boards that pass all these tests are packaged and sent to customers. So, where do these boards go? Particle boards are used in furniture, desks, wardrobes, cabinets, flooring, underlayment beneath carpets and tiles, construction, walls, partitions, shelving. They've become a backbone of affordable modern living, and all from waste that might have ended up in a landfill. And there you have it, the incredible journey of wood waste as it's transformed into durable particle board inside a supergiant recycling plant. In today's video, we're going inside a giant rubber recycling plant, where old, worn-out rubber is collected, shredded, purified, and transformed into something completely new. Comfortable sleeping pads. From the garbage pile to your camping trip, this is one of the most incredible recycling transformations you'll ever see. So buckle up, and let's dive into the journey of how trash rubber is reborn into products that help us rest easy. Rubber is everywhere. Just take a look around you right now. Tires on your car, the soles of your shoes, the grips on your tools, even the floor mats in your office. It's tough, flexible, and built to last. And that's the problem. Unlike organic materials, rubber doesn't break down easily. A single tire can sit in a landfill for hundreds of years, slowly leaching chemicals into the soil and releasing toxic smoke if burned. Multiply that by the billions of tires and rubber scraps produced globally every year, and you've got an environmental nightmare. Instead of letting old rubber pollute our planet, they transform it into useful, everyday products, like athletic surfaces, playground mats, road materials, and yes, even sleeping pads. Sleeping pads made from recycled rubber are durable, comfortable, and sustainable. They take something that once clogged landfills and turn it into gear that supports hikers, campers, and disaster relief shelters. This is the story of how we solve one of the toughest waste problems on Earth, by turning old rubber into something that helps us sleep better. The journey begins at the collection stage. All across the country, used tires, rubber mats, factory scraps, and damaged industrial belts are gathered up. Some come from recycling centers, some straight from tire shops, and others from massive junkyards filled with mountains of rubber. Trucks deliver this material to the giant recycling plant. Imagine a warehouse the size of several football fields, stacked floor to ceiling with rubber waste. It looks overwhelming, but every single piece will soon be given new purpose. Once inside, the rubber waste goes through sorting. Workers and machines separate the usable material from contaminants like metal rims, plastic trims, and dirt. Powerful magnets pull out steel wires that were once embedded in tires for strength. Conveyor belts move tons of rubber to specialized stations where cameras and sensors check for impurities. By the end of this stage, we've got pure rubber waste, stripped of everything else. It's dirty, cracked, and worn out, but still packed with potential. The next step is breaking it down into smaller pieces, ready for transformation. Rubber in its original form is too tough to reuse. That's why the next step is all about shredding. The rubber is fed into massive industrial shredders, machines with spinning steel teeth that can chew through tires like they're paper. With a deep roar, the rubber is ripped apart into chunks about the size of your hand. These chunks are then ground even further into granules, some as fine as grains of rice. This granulated rubber is called crumb rubber, and it's the foundation for all recycled rubber products. Depending on the intended use, it can be coarse or ultra-fine. For sleeping pads, the texture needs to strike a balance, small enough for comfort, but still strong enough to maintain structure. As the shredding continues, the plant produces mountains of crumb rubber. Conveyors carry it upward into silos where it waits for the next phase, cleaning and purification.